Okay, let's talk now very briefly. What happens when that nerve impulse, when that action potential finally arrives all the way down from the axon to axon terminal and is all the way down at the synapse? Okay. So, as you recall, a synapse is where the neuron is either going to meet another neuron or meet one of those four effectors: the skeletal muscle, smooth muscle, cardiac muscle, or a gland. It's where they're going to communicate. And in real life, it can be excitatory or inhibitory. I know in class, we're always showing you examples of an excitatory response where a muscle is going to contract or a gland is going to secrete, but always keep in the back of your mind that yes, it can be inhibitory. Okay. So the axon terminals in real life can, you know, form a synapse with dendrites to give messages to a new neuron, or they could form with the cell body. Here is a beautiful little photomicrograph of that. Here's actually an axon where they have color-coded inhibitory and excitatory synapses. So all the green ones are all the excitatory synapses, and all the red ones are all the inhibitory synapses, so that you can see that this one neuron is getting hundreds of messages and it's having to figure out what kind of outgoing message it wants to send. All right. And so this is showing this one cell body getting hundreds of incoming messages from axon terminals. And I know this gives me the heebie-jeebies, but this is much more accurate than when we're just showing one thing going to one thing. But for simplicity's sake, we're just going to stick with one cell going to one cell so that you can understand what is going on. So here's our example: one neuron going to one neuron with a synapse between them. And so when we're doing that, we have a sending neuron going to a synapse and a receiving neuron. And so the sending neuron is called the presynaptic neuron, and the receiving neuron is called the postsynaptic neuron. So the action potential travels down the presynaptic neuron to the synapse, where it's received by the postsynaptic neuron, which then can take an action potential and can send that down. The postsynaptic neuron can become a presynaptic neuron if there is a neuron or an effector at the other end. Okay, so just because you're a postsynaptic cell once, unless you are the end of the pathway, you can become a presynaptic neuron if there is another cell at the other end. So as you learn, when we learned about muscles, neurotransmitters are the chemicals that transmit the neuron's electrical signal into a chemical that the target cell can read. And these neurotransmitters are already made. They were made in the cell body. That's why there's so much Golgi up there in the cell body. They were made there. The vesicles are made, they travel down the axon, and they are sitting in the axon terminal and vesicles just waiting. Okay. So we have lots of vesicles filled here with neurotransmitters waiting to undergo exocytosis to be released in the synaptic cleft. And here is an electron photomicrograph showing this one drawing showed a mitochondria. So here is an electron micrograph, which actually shows a mitochondria and then a lot of vesicles here as well. So it took a while to find one that matches it exactly, but that's pretty close. All right. So what are some examples of neurotransmitters? Well, acetylcholine, we already learned about that with skeletal muscle contraction, but I want you to realize there's over 100 different neurotransmitters. We're not going to learn 100 of them. Acetylcholine is the one that you're really going to come out of this course knowing about. Some are active in both the central nervous system and peripheral nervous system. Acetylcholine is one of those. Many drugs that we give to people can affect neurotransmitters, and they can potentiate them or they can block them. You may have heard of dopamine, norepinephrine, serotonin. Those are all examples of neurotransmitters. Dopamine, that's your reward-driven learning. Like anytime, it's like anytime where I tell you, if you do this, You'll be getting extra credit. That's your dopamine neurotransmitter wanting you to do that. Okay. Serotonin comes in anytime you have the compulsion to continue trying, even though you're failing, even though you've tried free throws, you're going to try it again because you can do the free throw. You just don't know what your mental block is, but you know what you can do it. New memory is made with glutamate and GABA. So these are really important when it comes to Alzheimer's. Those are examples of neurotransmitters involved in Alzheimer's. Not going to talk about them in this class, but I want to talk about something related to neurotransmitters, and those are neuromodulators, but you may not have used those terms. But one of them I know you know about, and that's caffeine. And if I were to ask you what caffeine does, you would tell me caffeine is a stimulant, but it's not. Okay. Neuromodulators block the release of a neurotransmitter or change the response to a neurotransmitter. And what caffeine does is it blocks an inhibitory neurotransmitter. So caffeine is not a stimulator, it's blocking a blocker. And so by blocking a blocker, it's letting impulses go through that otherwise would not normally go through. And so that's why you're being stimulated. And another example of a neuromodulator are your endorphins that become released when you exercise or when you laugh. So watch a comedy, okay? And one thing that endorphins do, in addition to things like help build your self-esteem, and is they block something called substance P, which keeps you from perceiving pain. So yes, this lets you to work out. But if you've ever heard about like little old ladies like who may have accidentally backed up and run over a child or a pet, and then they can go and they can lift the car, and you wonder how could that 105-pound woman lift the car? Because their endorphins came into play and they could lift it, and so they didn't have any pain perception. Okay. So this is really cool stuff. And so hopefully you didn't find this part very complicated, because we're done with this section, and I'll see you when we come back, and we're going to talk about neurotransmission when we return. So once again, thank you for all your work, and realize that some sections are harder than other sections, and this one really wasn't one of the difficult sections. See you soon.